Hey, good morning, all the people who have joined. Let's see that everyone are there. Good morning, Padnavan sir. Thank you all for joining. I think a lot of participants are yet to join, so we will. Oh, it's already 10. So maybe another 2-3 minutes we will wait and start. By 11:10 we will start. So let the people join. Yes, the audience mics are not opened, sir. Just to avoid some noises, we can chat. So you guys can quickly check whether you are able to access the chat. At the end of the session, we will open up mics for the audience also. I think team is doing that. Okay, by the time the people join, let me start little bit introduction of Phytec. Not sure how many new how many of you are new to Phytec, but just like a SOP, standard operating procedure, let me just quickly go through the Phytec and then set the context why this webinar is, and hand over to Mr. Chaman, who is our smart energy meter expert, and then supporting academia programs at Phytec. Okay, so let's uh, quickly start introduction about Phytec. So phytec.in is the website you can visit, so that you need not to carry some PPT. So Phytec is a 40 years old German company, and then we are the OEM module manufacturers based on TI and NXP, but now we are also extending support for other semiconductors like ST Microelectronics and other partners. Rensas locally, we are supporting almost all semiconductor partners locally in India, starting from Renesas, Microchip, Qualcomm, and other core semiconductor companies. So, and then so when you say SOM module, basically, so we are a board, we come into a board uh, vendor category. So the chip companies build the chips for the different applications. We, as a module vendors, take the chip and build the system on module. If you see this small piece of hardware, it the system on module includes your processor, RAM, flash, and Ethernet IC and PMIC. So that you get a Linux running small module as small as 3 centimeter, 3 centimeter by 3 centimeter, right? So, and then we also provide single board computers. So these modules are then put into a motherboard basically. So there could be a standard development motherboards which will be uh, generic basically in nature, and anyone can use it. And then there would be a product specific single board computers like 5 gate, like this is a gateway application for HMI or another controls. for different verticals, starting from industrial, medical, transportation, and all, right? Okay, so Phytec also have a cam division where we do industrial embedded cameras. Basically, these are a high-end, high resolution and interfaced with embedded boards, basically. And then we also support the system level software development. So this is what all about Phytec is basically. So in India, we started 12 years back. It's actually 13 years back, wherein which there was a small company owned by me, merged with a 5 people team. We merged to Phytec and then started Phytec India. So today we are proud to say that like we are 75 plus team in India supporting these not only hardware sales, but a huge level of hardware design activities and then product development stuff, right? So the next one is basically not stopping ourselves with the products, basically. So we have also built a lot of solutions which accelerates these electronics companies to build their products and launch their product in a very less time. So starting with your digital factories, basically, so which is our core industrial automations part, then EV chargers, drones and robotics. These are the emerging technologies, but today topic is smart energy meters. So we are supporting big OEMs and then the smaller players in Indian market to for their smart energy metering, developing the communication technologies, developing the hardware and software for them. So other than that, like we have a climate monitoring system mainly for the agriculture solution. So likewise, this is a Phytec India initiative, and then where we have built a lot of solutions. The advantage of these solutions are these are the solutions which are used by companies to build their products quickly and launch their products quick to the market. But at the same time, these are available as kits or a development setups, basically, so which can be deployed in a COEs or lab setups and for the research purpose. Finally, I want to end up my introduction with the Rugged Board. So Rugged Board is a open source community started by Phytec India. So the idea was to uh, uh, make in India step, basically, so where we want to enable many developers in India to be a hardware developers and then build their open source single board computer. If not hardware developers, embedded developers who can use these boards. So this is an open source single board computer, industrial grade single board computer, which can be used to develop your product. But not only that, like you can use it for your own customized single board computer, where we are running a lot of initiatives. There will be a lot of hackathons, especially for the academia, basically. So there will be a lot of hackathons where in which the students and developers are supported and trained to build their own single board computer. So the vision for behind this community is basically, so if we want to compete with other nations, basically, where they are doing very good in hardware, so we have to uh, educate the young minds with these open source industrial grade open sources, basically, so which they could able to use and build their own hardware. So there would be a lot of hackathons activities. The people who want to learn the core board design with industrial grade, basically, so they can join this community, and then we are supporting a lot of trainings also. So here I close the Phytec introduction, and let's come back to the seminar, what we are a webinar which we are conducting, right? Smart energy metering solution. Now, why this is very simple, basically the need of the nation. So if you see here the numbers, basically, so already 22.42 crore meters has been sanctioned for all over India for different states. So this is the site link. All the links will be provided even at the end of the session. So National Smart Grid Mission, basically under National Smart Grid Mission, if you see that like these many meters are already sanctioned. And one thing is these are not all, this is only phase one, right? So there are other phases which will start. Okay, and you could see that like each state, how they are progressing with the smart meter installations, right? So Chhattisgarh, Madhya Pradesh, UP, West Bengal. Likewise, you can see because a lot of people would have joined from multiple states. So it would be nice to see the progress of your state, right? And then here, if you want to see the statewide progress, so you could see in numbers. So how each state, what all the numbers has been already achieved, or like they are sanctioned and then they are installing. So with this government movement, basically, so Phytec being a OEM partners, so we are not meter manufacturers, but like we help meter manufacturers to design the meters, develop the meters. Basically, they manufacture themselves. We help them to develop the communication, and we help the HES or like the cloud platform companies, which are the data companies. Basically, end of the day, the data is what like plays a major role. So the data companies, we again help with our hardware systems to achieve this smart energy metering system. So here I stop my introduction. Chaman sir, over to you.
Okay, sir. Okay. So my screen is visible, sir?
Yes,
Yeah,
sir.
yeah,
Okay. So let's start with today's topic, that is IoT-enabled smart energy metering solution powered by our 5-core IMX612 platform. So mostly we are focusing on the how smart meter IoT integration and real-time metrics. So okay. So our today's agenda is, first we have to understand what is smart energy metering system, and then after understanding the smart energy meter systems, we have to understand what is the smart energy meter basically. So after that, once we understand the smart energy meter, we have to understand the communication protocol, how meter can communicate to utility. So once we understand the communication protocol, we will move to the cloud platform. So means from the head-end system, how we will communicate with the meter. Then followed by, we will go for the live demo, and at the last of the session, we will go for a Q&A session. So let's start with the pitch. So first, we have to understand about the before understanding the smart energy meter, we have to understand about the evolution of the smart energy meter. So first one, if you try to understand, it's a electromechanical energy meter. So electromechanical energy meter, if you see, it's basically a rotating type disk. The disk is rotating means it will be directly proportional to the energy consumption. So whatever the energy you consumed, accordingly the disk is rotating slow and fast. And once the electronics evolved in the era of 1970s, then the what happened, now the CT and PTs are coming in the picture, and then we have some voltage divider, analog signal conditioners, some op amps. So with that integration, we will come up with the analog meters, and there the accuracy is more than the electromechanical meters. And in the era of 1980s or 2000s, we will come with the microcontrollers, and IC revolutions was there. So at that time, we will go went with the digital meters, where the accuracy is more than the analog, size is compact, and reliability is more. So After that, once the IoT the IoTs comes in the picture, so we will go with the AMR, that is automatic meter reading, where we will have features like communication are there, but communication is one way in the sense meter can send the data to the utility. Basically utilities are some companies will generate the bills. So previously, for if you see the traditional meters, there someone is come to your place and they will get the reading, accordingly the bill will generated. But when AMR come in the picture, that time what happen, the bill will that there will be might be a prepaid meter and postpaid meter. Bill will be generated, but what happen, it will be one way communication. So one way means meter can communicate to the utility, but utility cannot control the meter. If they want to, suppose that they will not pay the bill, so they will not able to control the bill, control the meter, means they will not turn on and turn off the loads. But as then the when the more evolution will go going on, and at the time of 2010 and later, now we will come up with the solution of a smart meter, where there will be a, that is advanced, it is a part of advanced metering infrastructure, where there will be a two-way communication. So two-way communication means meter can communicate to the utility and utility also communicate to the meter. So there will be a four stage authentication that we will see in the later phase. So this is how we will come up with the smart meter. So if you see that this is basically our smart meter, smart energy metering architecture. Here it will be broadly classified in three areas. So in area one, if you see, in area one we have a smart meters. On smart meters, there are different nodes, different smart meters. Now this smart meter, and there is a two routes. If you want to send the data, there will be two routes. Directly you can send the data through route A, or you can send the data, you can get the data from the customer. So customer, suppose we will try to understand like that. In smart meter, now in your home you have suppose that solar panels and some inverters. So now you are generating some energy. Now this energy you have to export to the grid. So the meters are integrated. So how much energy you are exporting to the grid, that will be sent to the meter to the grid. So that also communicate how much efficiently you are using your appliances. And then once you will get the data from the home through HEMS, now you have to send the data. So there is a uh, field area network, or we call the local area network. So local area network might be your RF based, it might be LoRa based, it might be Zigbee based. So you will send the data from smart meter to the concentrator. So concentrator is data concentrator unit that we will call the gateway, that will collect the data from smart meters through local area network. And once the data will be reached to the data concentrator unit, now it have to send to the utility means sub company. So how will send the data? It will collect the data from data concentrator unit. Whatever he will collect the data, he will send through the wide area network. Wide area network means through the internet. So through internet it will send the data to the head end system. Head end system collect the data and it will decrypt the data. It will understand, means the data it will send to the OBIS codes, mean DLMS format, it will see. And once the head end system get the data, the data will go to the MDMS, meter data management system. Some algorithms are there. It will decrypt the data, and how to generate the bill, that it will be passed to the different vendor companies. So this is what the whole architecture of the smart energy metering system. Okay. Now these are the different applications. So different application of smart energy meter. So first we have to understand the smart city energy networks. So if you see this is what the application of a smart energy meter. So smart city networks, basically, if you see the real time environment, we can go for the street light monitoring in cities, where we can have a different street light, and we will have some nodes are connected to street light, and we will collect the data. And then suppose some fault is happen in the street light, then we will without going to that location, we will understand where the fault is occur, and we can automate also. Means a fault is more than, suppose the voltage consumption is more than above some voltage, it will automatically turn off that turn off the supply to that particular street lights. Then other than that, if you go for the renewable energy integration with the real time solution, if we see, it's a solar plant monitoring at a factory. We can monitor the solar plant through our this uh, solution. Then if you go for the educational and R&D test bench, where we have, if you see the real time, you can student can monitor the real time power, voltages, threshold, total harmonic distortion, how much harmonic distortions are there in the supply, load profile. Okay, then if you go for this microgrid energy control system, so what it means, if you try to understand, it's a microgrid means campus gather the factory. That means be local energy monitoring and industrial power balancing should be there. And so real time, if you try to understand, means it's a industrial microgrid. So a smart meter installed at the plant, DG sets and load center. So how it will means, suppose if grid fail, it will switch to the DG set. And if battery full, it will understand now battery is full, we have to go for the, we have to now the whatever the solar is generated, that we have to export to the grid. So that also we can go with the microgrid. That is also one application of this one. Then predictive energy and appliance automation, where the real time application, if you see, it's a predictive maintenance in manufacturing plant, where if you see some motors are having some fault, we will detect that fault. And or if the suppose if the voltage, if the temperature level of some binding of the motor binding is more than that one, some threshold value, it will detect that one, and accordingly it will turn off the supply to that one. And it will load forecast also, how much energy it is getting from the supply. And if you go for the smart industrial campus, where we have a smart campus pilot project we can deploy, and smart campuses also we can go with this flow. Then if you go for the this one, miss, building energy management, so we can manage the HVAC, high voltage AC transmission, server rooms, lighting. So in each floor we can put one smart energy meter, and we will see how much energy there is consuming. So accordingly we can manage the our energy consumption, and we will understand, means if this is the energy consumption, how much we have to forecast. Load forecasting is also possible for this one. In industrial energy, if you go for the industrial energy optimization, where we have a meter installed, suppose it for compressor, molding machine, conveyor belt and other things. So these all are the basic application of smart energy meter. So now once we understand the what is smart energy metering system, now we have to understand the what is smart energy meter. So this is basically one prototype of a smart energy meter, where we have a NXP Cortex M0 Plus SoC, and it's a MKM35Z512 processor. That is now it is, if you see here we have a display units. Okay, and we have done one crystal oscillators are there, and we have a GPRS modules, we have RS-232 communication, we have temper reduction. If some tempering is happen, it will give the alert to the utility. We have auto push, you can if you push, it will just scroll to the next reading. And here some IR the communication LED is also there. So suppose if it is connecting to the internet, it will communicate, means it will show. If the LED is blinking, means some communication is going on, communication stabilized properly. So then some active energy consumption, power, everything will display over here. Then here you can give the supply and load. So here internal CTs available, and some switches is also available. So this is basically a one prototype of smart energy meter that is having, I think, GPRS based. So different depending on the communication, we have different modules. So one way, if you understand what is smart energy meter means, the meter can communicate. Communicate means whatever the data meter will read, it will send to the utility. So how it will send to the utility? Either directly it will send to the utility, or through DCU it will send to the utility. So directly when we have a cellular type, so 4G module is there, it will directly send to the utility. Or if we have if we have RF module or PLC, that time it will send the data to the data concentrated unit. Data concentrated unit will get the data, and then it will send to the head end system, MDMS, and then utility. So it's a basically one ecosystem where there will be a two-way communication. So meter will send the data to the utility, utility also communicate to the meter. So if you see the types of smart meter, so there are, depending on the connection, means how the smart meter is connected, will be a two type. One is the whole current smart meter. Whole current smart meter is the meter where the CT is present internally in the smart meter, and it's falls in the class 1. So class 1, if you try to understand what is the class 1, so class 1 is basically the error in reading the meter, reading the error is 0.1%, plus minus 1%. Let it be, suppose you are reading the you are consuming the energy, suppose 100 watt. Okay, then if it is a class 1, it will show might be 99 or 101. So 1% error might be there. So that is fall in the class 1. So this type of whole current smart meter, it's fall in the Indian standard 16444 part 1 standard. So basically, if you go for this whole current smart meter, there are two type, basically single phase and three phase. Now if you see in our consumer end, in consumer end, we are deploying this type of smart meter, single phase whole current smart energy meter. Mostly whatever, means if you use a 250 million smart meter, they are deployed with the single phase whole current smart energy meter. If you go for three phase, suppose some industry need three phase, some power stations, some substations, some grids, they need three phase, they will go for this three phase. But the thing is, the current and voltage limits is there, because it don't have any external CT and PT. So internal CT means the current range is maximum of, it will go to 100 ampere, not more than that, or 20 to 50 ampere. And voltage range is what? For single phase 230 volt, and for three phase it's a 415 volt RMS voltage. If you go for CT operated smart meter, it's having a external CT. So in spite of internal CT, there might be external CT and PT. So it fall in the class 0.5. Why it will class 0.5 and 0.2? Yeah, you understood what is class 0.5 and 0.2 means. The error is 0.5 and 0.2%. Now why this less error? Because when you go for the CT operated smart meter, the energy production, energy consumption is very high in the megawatt and the kilowatt. So that time the small error is also lead to the more loss. So that's why it is fall in the Indian standard 16444 part 2. And here now it will also divide in the two way, LTCT smart energy meter and HTCT smart energy meter. In LTCT smart meter means low tension current transform smart meter, it will having now external CT, because here the current range is more than 100 ampere. That's why we are going for the LTCT smart meter. If so, this type of smart meter, LTCT smart meter, used in the substations, basically where we need the three phase supply and high current. If you go for the grid type, where the current is also very high and voltage is also very high, there we will deploy the HTCT smart meter. So the range of this current is more than 100 ampere, and the range of the voltage is more than 11 kV something. Okay, so once we understand that depending on the connection, how what type of smart meter, if you want now meter want to communicate, means how the meter will send the data. So that type of, if you will categorize the how many types of smart meter depending on the communication, how it will communicate, how it will send the data to the head end system or utility. There are two types basically. One is the wired, another one is the wireless. So in wired we have a PLC, power line communication. And in wireless, we have two. One is the cellular network, where we have a GPRS, 4G, 5G, narrowband, Wi-Fi technologies. Other one is the RF mesh, where we have a Wi-SUN, WirePass, TINI, and ZigBee, LoRa protocols. Where so this is according to the communication, how the meter can communicate. Meter can send the data to the head end system, and then MDMS, then utility. So if we understand the architecture of smart meter, so architecture of smart meter, if you see, previously we have a digital meter. So in digital meter, if you see, we have only two modules. One is the metering module, another one is the data exchange module. In metering module, what it will do, it will having some metering IC, it will having the CTPT that will read the data and generate the water energy consumption depending on the current. It will read the current, it will read the voltage, and when we multiply voltage and current, we will get the power, and how much that power, how much time you can consume, you will get the energy. And it will having the some power factor or power factor meter also that will measure the power factor. So once you multiply voltage current with the power factor, you will get the power, and when you multiply the how much time power is consumed, you will get the energy consumption basically. So once you read the data, you will read the voltage, current, power factor, active power, and apparent power, energy. Now you have to, once you read the data, now someone will this once meter will get the data, someone will find what is the data, means how I will generate the bill, how much energy you consume. So now it will go to the data exchange protocol. So here if you put optical meter reader, it will get the data from this data exchange protocol. Once it will receive the data, it will understand, okay, this month you have this much energy you consume. Now this is according to the that some factors are there for calculating the bill, some multiplying factor, some if you some reactive power and generated, then some reactive power penalty factor is also there. So accordingly they will generate, so per unit how much, according to the state, how much they will put the price, they will give you the billing cost. So once they will get the billing cost, you have to pay. That is the data exchange protocol. You read the data from optical meter reader. Now in a smart meter, they will add two module means one is the communication module, another one is the load switch. So what communication module will do, once you read the metering parameters or energy, now you have to send this one without anyone will come to your location and read the thing. You have to send this one to the utility, some that company, but the descom and something where they will deploy. So now how you will send this data? So these are the communication module. Now if we have suppose RF based, PLC based, so that time we have some here modem. If I go over PLC type, so then that time this neighborhood area and local area network, I will put here PLC modem. If I go for RF mesh, I will put here some NIC card, network interface card, RF based. Now once it will read the data, now it will send the data. If it is, it will send the data to where? If it is a local area network, it will send the data to the DCU. DCU basically one data concentrated unit. It will collect the data from this smart meter. Once it will collect the data from the smart meter, it have to send to the head end system. So that is communication. Now suppose it will get to the head end system, and then from head end system it will reach to the utility. Now suppose it is a prepaid smart energy meter, you didn't pay for that one, then they will turn off your load. So how they will turn off your load? They will send one command, disconnect command, and it will come to HES, it will go for DCU, it will come to your meter, and then it will go for load switch. And load switch having some electromagnetic switch that will turn off your load. That is how this basic smart meter architecture is working. Now if you see the DLMS COSEM architecture, so now we have to understand what is DLMS, why we need DLMS. So suppose I am talking to you right now in language is English. Now meter want to communicate. How they will communicate? They also have some language. So now for meter want to communicate, the language is DLMS. Not only this energy meter, any metering device, you take water meter, you take fire meter, you take gas meter, they have now at a standard, they will follow the DLMS COSEM protocol because it's a interoperable. Anyone can use, any vendor who can manufacture their meter, they have to follow this protocol. It come up in India in Indian standard 15959. So now if you see the architecture of, once you understand what DLMS, it will be a communication protocol basically, how the meter can communicate. Now, if you see the architecture, one is the data model. In data modeling, what is happening? In data modeling, we can model the data. So we can model the data where uh, where we have a COSEM of COSEM is also there. So COSEM is nothing but the companion specification for energy metering. Depending on the country or state, the COSEM protocol is different. But DLMS is all over the international. It is the same, but depending on the countries and different tariff rate, the COSEM protocol is different. Now, so in COSEM also, how to model the data. So there is a OBIS code is there, that object identification codes are there. So you will consider this data model as a dictionary that defines what data is available. So at which, suppose I want to read the voltage. So at voltage also having some OBIS code. If I want to read the current, so current is having some specific OBIS code. Any vendor want to read the data, he want to put the data in that specific OBIS code at this register level, the register, so that if you want to fetch the data, you will go to that register at that OBIS code, you will get the data. After that, once you will get the data, model the data, then it will go for the application layer. So in application layer, it will basically handle the authentication, it will handle the handshaking protocol, data read and write, how we will read the data and write the data. And majorly, if I say communication sequence, what is going in the application layer, you will think it like it's a brain that run the communication and security. So here we have a 4-step authentication of the data. One is the meter. This meter will send the AARQ request to the client. Client means who is want to get the data from the meter. So first it will send the AARQ request, and then meter will respond that AARQ request with ARE response. Then if the client want to read some OBIS code, he will send the get command, and then meter will respond with the how much specific to that OBIS code, it will respond to the that data. Now after that, we will go for the data link layer. In data link layer, we have to understand basically SDLC is basically high level data link control. So here, if I want to read the data from, suppose I want to read the data from the optical meter reader or RS485, that time we will go for this SDLC header. In that SDLC header, we have a SDLC envelope, we have a SDLC header, and we have a OBIS code also. So here we can directly read from RS485, we can read from optical meter reader. If I want to go for the suppose RF mesh, wirelessly I want to read the data from the meter, that time I will go with the TCP/IP and I will go for the NIC card, network interface card, and if it is cellular, I will go for the GPRS modem. If you want to read the data from the power line communication through wired, then we will go for the PLC header. We have a PLC modem. So this is how the DLMS COSEM architecture framework is working. So now once we understand the smart energy meter, we will understand what is smart energy meter system, what are the whole architecture. Then now we understand what is smart energy meter. Then now we have to understand the communication protocol, means how many communication protocols are there. So if you see the communication technology, one is the wireless star network, another one is the RF mesh network, and PLC. So wireless star network, if you understand, so here we have a 3G and 4G LTE. Suppose now you have some cellular network. Okay, so cellular network, they want to send the data to the base station. So every meter have their 4G module. So now 4G module, each meter will send the data to the base station. So then from once the data will receive to the base station, it will send to the another substation. Then from substation to the over the internet, it will send to the HES and then MDMS. And if you go for the RF mesh network, so in RF mesh network, if you see, these all are the meters. So means we have different smart meters. Now this smart meter want to send the data to the head-end system and then utility. How it will send? It will not directly send, because in this RF mesh, each meter have their NIC card. So NIC card, it will network interface card, it will send the data over RF. Now the range of radio frequency is basically, we will say it's a 500 to 600 meter. So now from 500 to 600 meter, that is local area network, it will send to the data. So where it will send the data? It will send the data to the DCU. Now suppose in your colony, let it be in your colony, there are 200 houses, and now your DCU is connected to in some pole. In pole, now the DCU will collect the data from all that 200 houses. So first 2 or 3 houses, they are nearby the DCU. They will get the data from the first houses because that is in the range of 500 meter. But what about the other houses who is not in the range of 500, 600 meter? So now here comes the RF mesh network. Means mesh network means, if suppose that meter is not in the range of DCU, then that house is in the range of another smart meter. So in spite of directly sending the data to data concentrated unit, it will send the data to the nearby smart meter, and that meter will send to the another meter, and who is in the range of the DCU, it will send to that DCU. That is one thing. So, and once the data will receive to the DCU, it will send to the head end system, and from head end system it will go to the MDMS, then utility. Now another question is how this DCU will understand from which meter I am getting the data. Correct? Every meter have the data. Now how it will understand the data is coming from this meter and this meter? So with meter it will send their IPv6 address. Basically it's a IPv6 protocol. So they will send their IPv6 address and MAC address. So every meter have their unique MAC address. So when they send the data, they will send their information that I am this guy, I am sending this data. So accordingly they will understand the data is coming from which meter, and then meter will aggregate the data and it will send the data in the DLMS format only. But in HES, once it will go for the head end system, it will decrypt that DLMS format, and some encryption is also going on and some security is enabling, so that all will be done in the HES. Then in PLC method, here we have a wired communication. So wired communication means all meters will send the data through the power line. Okay, through the power line. So PLC is power line communication. So they will send the data to the power line. So each meter have one PLC modem, and the data concentrated unit DCU also have one PLC modem. So the DCU will get the data from each meter over the power line. So they will form one network, and each meter have one node ID. So they will send the node ID so that they will understand from which meter the data is coming. So after the communication technology, we understand how many communication technologies are there in the smart meter. And now we have to understand what, as a Phytec, what we have for industries and for university. They have to incorporate these things, this kit in their curriculum. So here we have this focused the solution for smart meter as a prototype. We develop this thing. So here we have one smart energy meter, and we have a NIC card, network interface card. This is basically RF based, and we have basically one load and DCU. So this is basic architecture. So here we have a meter. We have developed our 5-wave FG28. So over RF module, we will send the data. We will get the data in RBDCU. Once we will get the data here in RBDCU, we will send to this over head end system, and head end system will collect the data and it will decrypt the data. And once it decrypts the data, it will send the data to the dashboard. So here for this our development, we are using the Thingsboard dashboard. So over MQTT, message queue telemetry transfer protocol, it will send to the Thingsboard dashboard. Now this is basically RF NIC card, that is 5-wave FG28. So this NIC card having the it is having the Cortex M33 processor, 32-bit ARM processor, and its operating frequency is 78 megahertz. And if you see, it's a processing core is so if it's basically a microcontroller. If we try to understand, basically a microcontroller. Over than microcontroller, it is having a radio module is also available. So radio module having the radio band is 2.4 gigahertz, and BL is also available, and the transmission power is basically 10 decibel. So and if you see the block diagram for this one, so for giving the power, so from the it need 3.3 volt to get the power, and for flashing the firmware, we have to flash through the SWD serial wire debugger flasher, and we for external, this is having the antenna, that is the external antenna, and internal, both type of antennas are available to send the data through the RF module. And then it is having the for interrupt, it is having the GPIO also, it is having the UART also, universal asynchronous receiver transmitter. Then data concentrator unit, if you see, so this is our DCU. If you see the DCU is, if you see the, it's a central intelligence of smart meter, or it's a IoT for IoT development. So if you see, it's collect the data from the multiple field devices, and it will also perform the remote control, diagnostic, firmware update, and event monitoring. So if you want to update the firmware in the in any smart meter, so that also you can update over the air. If you want to update the firmware in your DCU, that is also you can do from the over the air. And now if you see the power architecture, it required 5 volt DC and 3.7 volt lithium ion battery is also there. And if you see the storage system, it is having the eMMC and operating that eMMC and SD card is also available, micro SD card slot, where the operating system is running. And as a network option, if you see that, that is the, if you see the networking option, that is the backbone of the DCU. It is having the wired, that is Ethernet, and wireless also, Wi-Fi also. MPCI slot is also for 4G module. And if you go for the wireless positioning and connectivity, it is having the RF connector for GPS and LTE, and it is having the UART, 7 UARTs are available, and SPI I2C for industries. It is having the CAN and Modbus RS485 is also available. It is at the optical UART also available. For security layer, we have the TPM also, and temper detection also there. Secure boot is also available. So mostly whatever we need for the, as a DCU, we have all implemented here. And for industrial grade input output, it is having 24 volt input output is available. SPI is LCD interface is also available. Okay, so this is all the features of this data concentrated unit that will be provided by us. And then if you go with this block diagram, already I explained, means this IMX6UL, the core we are using here is the IMX6UL. Now this IMX6UL need the so from the power supply 3.3 volt will come over here. So to voltage regulator, it will just give the voltage, whatever the voltage needed. Suppose 1.2 volt, it will give to this IMX6UL SOC. And then DDR RAM, that also required some voltages other than 3.3 volt, that also given by the voltage regulator. Then EEPROM memory is available, Ethernet 5, and NAND flash for flashing the code. So these all things are there already explained. Okay, then we will go with the means now we have to understand Bison. So Bison, basically, if I say in my kit I am using the RF mesh, correct? So RF mesh, now for sending the data, connecting this meter to the DCU, we are using the Bison stack. So Bison stack means wireless smart utility network. So it's a IEEE 802.15.4 based standard that will be IPv4 enabled. Sorry, network issue was there. Let me continue. So if we want to communicate with smart meter, want to send the data to the DCU, the protocol we are using the Wi-Fi. Wi-Fi is the wireless smart utility network. So as a layer, if you try to understand, is the hardware layer where we have FG28, then we have as a physical layer we have a rail, and as a middleware layer we have a Wi-Fi stack where we have a IEEE based MAC layer, and we have a 6-LoWPAN layer where we have routing and encryption is going on, and we have a UDP layer, and all layer having the security EAP TLS and AES 512 securities are available. And for this one we are using the socket implementation, and application layer we are using the socket. Okay, so in Wi-Fi we have a RF mesh network. Now how one meter can communicate with another meter, and that meter will send the data to the DCU. So all the backbone is this Wi-Fi stack, how they will configure. Now we will go for the what is PLC, power line communication. So power line communication, already told, we will send the data to the through the power line. So through the power line. So means it's technology is going on. It's not implemented right now, but it is on the development phase because of the SN signal to noise ratio is not in the desirable limit. So that's why it's still going on. But this might be the one future for our smart metering also. So if you see as a Phytec, we are providing this solution where we have a smart energy meter. We have this PLC modem, and here one PLC modem connected to our DCU. So over the power line, they will send the data. So they will form a one network. So over the network, so this every PLC modem have their own ID, node ID. So which meter will send the data, that will be registered here in the main modem that is connected to the DCU, and then it will understand from which meter the data is coming. And this is the basic this is what the architecture of this PLC system, where we have a PLC modem, we have a load, and this PLC modem, this is the wired coming through the power line, power wired, and this is also going to the main PLC, that is the RBDCU. So they form a one power network. Then once the data will reach to the DCU, it will send to the HES and then to the dashboard. So this is all the power line communication protocol, where we have a smart meter devices, and then we have this IT908 modern, that wireline chip. Using that chip, the data will go to the wire to the DCU and then connect to the cloud, and here we will, from here cloud, we will control the meter. And this is all the parameters of this IT908 chip, that is 32-bit PLC SoC, 26.3 megahertz CPU, okay, 33 KB RAM. Okay, so this is how that data is going to the power line. So whatever from the where we are getting the power, so that power line only we will send the data. So that is saving of the wire, basically, if you say. So this is the specification of the DCU, that is the RB-IMX6UL. That's already, I think, I explained. So this is basically the block diagram of our DCU. And now if you go for the cellular technology, so in cellular we have integrated this Indian standard 16444. I already discussed in starting only. So here, if you see in meter, we have a cell tower. So here in cellular, we don't need any external DCU. So you can directly send the data to the, but the disadvantages is suppose the metering cost is you have to pay for the running cost also. If you put the 4G module, the SIM is there, so that running cost is also available. And suppose in the later time technology is updated, so that time you have to update, you have to change that 4G module also, that 4G or 5G module, whatever you are using in the meter, that also you have to update. And everywhere you will not get the signals, that is also the one issue. So there are some other points also. So that's why we are mostly, some companies are focusing on the cellular also, where we in urban areas and some rural areas where the network is not available, there we can go for the RF also, and running cost is not there in the RF. So that's why we can go for the RF also. So this is the basic architecture of the cellular, where we don't have any local area network. So through meter only we will have here 4G module, So through the wide area network over the internet, it will send the data to the head-end system. So once we'll complete cloud platform, we will go for the, this is our head-end system. So head-end system is basically, we have a, from cloud, how we will see the all the data. We will see the voltage, current, power, energy, apparent power, power factor, and we will control the load also. We will see the instantaneous profile. We will see the nameplate profile also. So now we will go for the live demo. So before that, I will hand over the mic to the Vasu sir. Vasu sir, over to you.
Hey, hi. Chaman sir, am I audible?
Yes, sir. Yes, sir.
Okay. Can you stop sharing your screen? Maybe I overtake. Okay. So hopefully you got a lot of keywords if you are new to energy metering things. And then parallelly after demo, like we will have a Q&A sessions, and parallelly we will answer most of your questions in the chat. Before that, like I just want to do some PR basically. So as we told, like we have these solutions. So these solutions, so the biggest initiative what we took here is basically bringing the industry and academia together. So the idea is to promote product research and development uh, starting from academia, so that like by the time the resources goes to industry, they are doing bigger innovative products, and then bringing the technologies together. So that's how as a Phytec. So when you see that, like why Phytec team is spending so much of time and energy being a OEM, right? Like, so as I told, we are a 40 years old German company, and we are making this small piece of hardware, which is like, you can see this here on the screen, it looks big, but like it is as small as 4 centimeter by 4 centimeter, right? So now as a OEM, so why we are promoting this solution is very simple, and then why we are promoting this solution not only to the industry but also connecting it to the academia, is because we want more and more companies from India to design, develop, and manufacture the products in India, and Phytec be an OEM. So we do support them with all level of technologies and technical expertise, starting from hardware design, manufacturing, and software development, right? So what our team has tried to do is basically we started building solutions, not only the hardware, but like also we are trying to build the solutions. So you could see one of the solution is climate monitoring system. So one of my uh, great friend just requested me one saying that, like, hey Vazu, like I want to do some monitoring in my coconut farm, and then like um, and also I want to do it automated and then pass the data to AI, so that like the agriculture university from Tamil Nadu can do the data analysis and help us to find out the alternate crops basically, right? So you could see over here, whatever you are seeing in smart energy metering, that the data travels from the meter to the gateway to the cloud. The similar setup we have done for the agriculture use case. So here you could see the directors from Tamil Nadu Agriculture University. The use case was the coconut trees are dying because of root wilt, and then the local farmers want to have some alternate crops and also try to do some analysis on the climate effect on the crops basically. So again, here you would see that, like whatever you have been discussing, more or less the same stuff. You could see that, like there is a gateway, there are different nodes which are again based. So these are the major three concepts you would have looked on. So 5 sense which could be a sensor controller, gateway, and the cloud, right? So you can develop such kind of systems basically. So, and these systems are not something like very, uh, uh, these systems are available in the form of kits to the universities where you can put it in your lab and do the real time development. And then today, a lot of universities have started a lot of branches on computer science, like data scientists or AI and all, right? Like, so when you don't have a real data, you cannot do the analytics, you can't do the AI model development. So the 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 technology is moving towards, when you say AI, and what you are developing as an AI expert basically, so you need to have a real time data. And then, being an embedded company, so we are enabling this edge computing and real time data collection. So real time data collection is through IoT, and AI on the edge is through our edge computing. So for that, like, merely in every of these solution, you can find IoT and embedded edge computing basically. So these are available as kits for the universities. These are available for the development kits and reference solutions from the for the industries. For the students, it is available as an open source where they can go to the next level. And not only that, so you also are given with a comprehensive training on these systems. So now, whatever you have gone through in this 1 hour of smart energy metering webinar, if you want to do a full-fledged course and do whatever you have heard now, if you want to do by your own and professionally, so you could see that, like, all these things you can learn practically and develop with us. So this is how we extend our support. This is how we extend our support by providing the real-time industry solutions to the academia, so further to the students basically to build their career. So I, being a 20 years of Masters of Electronics, graduate of computers and electronics, I'm proud to say that, like, whatever our knowledge is passed to the next generation by the mean of the products and solutions we are developing. So we would be happy for the academic institutes and for the students if they are able to utilize the technologies which are currently being used in industries and supported by Phytec as a OEM modules we do support. So that's entirely a different business. But, like, these industries need a lot of skilled engineers. And this session was specially meant to give the overview of different technologies starting from smart energy meter, but, like, we would have a multiple workshops basically which will follow. So there will be a series of workshops. We will request you guys to participate and motivate basically your colleagues, and mainly the faculties. We want to uh, do these awareness programs so then they can pass it to the students basically. So we give it at a university level, we enable the faculties, we set up the labs, and then they can utilize these industrial grade hardware and software, open source, and most of them are open source driven. Right? So just for a quick view, if you see, so this is all the solutions which are available starting from digital. So the next webinar would be on the digital factories, which will be based on this industrial IoT gateway and open source called ThinEdge. And we would be also having a webinar on open source EV charger development. You all know, like, what would be the future of EV chargers, similar to the energy metering today. What you are saying, like, we have a lot of scope on water meter, gas meter, but You just imagine when you are thinking of smart metering in terms of energy, water, and gas. Just go back on the technology side. These all are IoT. So once you see that like this big IoT deployment happens in India, so what would be the IoT future or AIoT future from India to the globe? What you can develop. Today, we are only connecting three devices from each home in India. Don't you think it is the biggest, it would be one of the biggest IoT project in the world? And once we achieve that, what will be the future of Indian engineers who are developing this kind of technology globally? So these same energy metering or energy analysis goes to the each machine level. Today we are talking about a home, and tomorrow we will be saying each machine which needs some energy to run, what would be the energy consumption of each machine? It will go to a level. So those are the futures where we are guiding you to build your knowledge and bring the hands-on experience basically, right? So we also support on robotics, drones. So these are the industrial solutions which we build, but also available for academia to adopt. We set up the lab, we help them to give the detailed training for the faculties and as well as for selected students. And students can also register directly on our community site, and they can do so. We do provide short-term courses. So these are like all our university initiatives, so that like our electronics industry get a talent pool which are ready to develop products basically. Here I would like to stop and let's proceed for the demo, and please ask questions in the chat box, so our team will be replying to them. So over to Chaman sir.
Okay, thank you, sir. Yes. Okay. Okay. So as you see here, we have a one dashboard, and here what we are doing is we are basically this is our basic setup kit, where we are reading the data from the optical meter reader. This is our OMR. So right now I am not going for the RF mesh. First we have to read the data from the OMR itself. So from OMR I am reading the data, and on the back end I am running the Guru's DLMS director, the SDK, that will get the data and send to the dashboard. So this is the dashboard where I will read the data, instantaneous values, and I can from here also I can control the data also. And I implemented some AI also, AI script also over here. So to protect the data, to protect the system. So if the voltage is greater than 270 volt, it will turn off the load automatically, and that will give the protection from the supply side. And if the voltage is if the active power is greater than suppose 400 watt, it will turn off the load also. So from the suppose load side, if the voltage is suppose the energy, the power you are using is this much and this specified level, if the voltage, the active power is greater than that one, that then what happen, it will turn off the load. So that two factors I implemented over here as a AI. So that time, now if you see, if I just go for the read instantaneous profile, it is reading the profile. Just a minute. So first the authentication is going on. So it's the DLMS authentication is it will understand, means it will be ARQ and other things. So once it is understanding, now if I just read the instantaneous profile, it is reading the instantaneous profile, and you see here, let me read one more time, then I will show you. So see here, the voltage is 240 volt, current is this one, power factor this one, and if you see here, this is the data we will get over here. And now if I want to connect the load, I can go for load connect, and it will connect the load. See here, now load is connected. If I want to disconnect the load, I will disconnect the load also. Load is disconnected. And now suppose the voltage is, so right now the voltage is 240. So suppose some telemetry, if I send the voltage more than 240 volt, then what happened? More than 270 volt, then what happened? It will automatically disconnect the data. So let me first connect the load, so that practically I will show you that also. So now load is connected. Now if I send the voltage greater than 270 volt, then it will automatically disconnect the load. So if you see, now voltage is 280 volt, load is automatically disconnected. Now for the load side, if the active power is greater than 400 watt, so right now for practical demo uses, I put the watt power usage is 400 watt. If the active power is greater than 400 watt, then it automatically disconnected. Let me connect again, so that I will show that also. Now load is connected. Load is connected. Now if I send the active power greater than 400 watt, it will disconnect. So now see, I am setting the watt is 400 greater than 400 watt, load is disconnected. This is how I am reading from the optical meter reader. Now we are going with our next demo, that is our RF mesh. So here we will read the data. We will read the data from the meter. So this is our, now I will just take out this optical meter reader. Now here we have a data. Now I will connect, and we have a one data concentrator unit. This is our DCU, and we have a NIC card also, network interface card. That is one in the DCU, one in our smart energy meter. So now I connect my DCU with this Ethernet cable, so that it will connect it to the internet. And for if you want to see the logs, I will connect that this our DCU. And so we are giving the supply to the DCU. We will get this the NIC card. It will get the data. So now this smart energy meter is there. Now load is there. Now this NIC card is also available here. The meter will read the data, and NIC card, once it will get the data, NIC card get the data from the meter through UART. Once it will get, NIC card will get the data, it will send the data to this NIC card over the RF. Once it will get the data, now from here it will get the meter will get the data through UART. The DCU will get the data, then over the Ethernet it will send to the head-end system. For head-end system, we have this dashboard. So you see, this is our dashboard for our RF mesh technology, this RF mesh demo. So if you see here, now let me just give the supply to the this also. So now let's just okay. Let me connect. Okay, just a minute. Okay. Just a minute. Now if I see, now this is the instantaneous profile. If I want to click on the instantaneous profile, it will read the instantaneous profile. So here, click here to get the instantaneous profile. If I click here, yeah, it will read the data, and we will get the data over here. Just it will take time because encryption is there, SDK is running here, and it will encrypt the data, then send the data to the cloud. Without encrypting, it will not send the data. So now if you see, we will get the data over here: 240 volt frequency, phase, neutral current, sine power factor, apparent power. So all this instantaneous data we will get over here. Now we want to see the nameplate profile. So about the, you want to read about the meter ID, who is the manufacturer, firmware version. So you can click here, you will get the meter profile. Okay. I will share my screen better now. Okay. So if I want to connect, I will just go for the load connect. It will go and the load will connect over here. If you see that, yeah, I think 10 second it will take time to encryption and decryption and send the data over the cloud. Now the load is connected, and the same way you can disconnect the load also from here. So this is how it is from this smart meter. It is over the RF. It is connected. So here in the demo we will show the 1 meter. Likewise, it is having the 100 and 200 meters. Will send the data to single gateway. So single gateway will go for the 200 meters. Get the data from the 200 meter, depending on the stack you are using for the routing procedure. Okay. So I think that's all from the demo end. Now we will move towards the Q&A session. Prasanna ji, please open the mic for the audience. So
Thank you, everyone. I believe our team tried the best to pass the knowledge, and we would be happy to connect back to you. And then, like, there are series of workshops, webinars, which will be uh, continued. I think during COVID, we have run open session and technical sessions. So the same, we would be happy to continue similar kind of events. We will be supporting, conducting in future. So please follow us and then like register to the community.ruggedboard.com basically. So similar to this, like we will be conducting a lot of sessions. So even you can leave some quick messages on the feedback on the chat screen. And if someone want to speak, maybe 1 or 2 minutes we can give. So I believe this was the best session which our team could complete on time, I believe. उसको सेटिंग में जाके ये करना फॉर्म सेटिंग्स में एनीवन कैन रेस्पॉन्ड ओके anyone can respond.
PDF format, syllabus name. PDF format.
You type. So I think now you can access the form. So Prasan, can we open up the mic for some Q&As?
It's open sector.
To all? Okay.
Yeah.
No, for others, what I mean to say. If you have any questions, please put in a chat or like put this thing so we can open up the mic, but like your feedback will help us. So thank you all. See you in the next webinar. हाँ हाँ और ट्रेनिंग्स वाला फुल फोल्डर फुल लिंक डाल दिया था तो फ्रॉम देयर दे कैन एक्सेस For industrial internship. Please register. So thank you all. I think we will stop now. In case if you have any other requests, complaints, requirements, I believe our contacts are there. You can connect to our team anytime. So there are email IDs and phone numbers available on our websites. So community.ruggedboard.com, phytecembedded.in, phytec.in. So request everyone to explore the opportunity to associate, and we would be happy to work together. Thank you all. We'll end the session now.